Hi, I'm Peter Martinson. With me is Ben Denistone. We're with the Larush Political Action Committee, and we're going to give a short presentation which expands on some of the material that Lyndon LaRouche has already presented at the keynote of this conference. Now, every generation has its visionaries. For example, a little over 100 years ago, we had Konstantin Циолковский, who was one of the greatest rocket visionaries of our time. Today we have people like Lyndon LaRouche, who is one of the greatest economic visionaries of the past 50 to 100 years. Now, the key to the visionaries, we need our visionaries. Because one, they inspire the younger generations to become great and to have a vision of what the future entails for them. But more importantly, as Mr. LaRouche makes clear in his concept of physical economics, the visionary is crucial for all economic growth. Now, economic growth is measured not by money, not by how much money, how much monetary profit you make, but it's measured by increases in what LaRouche calls the potential relative population density, which is how many people you could potentially support per unit area of land, per hectare of land. Now, it's a measure of your technological advancement, it's a measure of your power over the environment. It's a measure of how well you can support a population. Now, what goes along with increases in potential relative population density, as we've seen over the documented history of mankind, are increases in what LaRouche also calls energy flux density. We've seen this in the development of nuclear fission earlier in the 20th century, the mastery over the basics of nuclear fusion to make fusion bombs, and then the indications of potentially mastering the reactions between matter and antimatter. Each one of these types of reactions is a higher energy flux density. It's a higher concentration of flux of energy through a given unit of area. And every increase has always been paralleled with an increase in your potential relative population density. And what this means is that the core of real economic growth, in terms of physical economic growth, comes from the discovery of universal physical principle, which means you have to have visionaries. This is the importance of visionaries in your economy, because that's the source of the knowledge of new discoveries. So what you would call a sane government policy, a sane government economic policy, is what Lyndon LaRouche called the science driver policy. The government has a mission to define where are the boundaries in scientific knowledge. And then the government has a responsibility to invest in making the breakthroughs in those crucial areas of scientific knowledge, because that's what leads to the improved survival of the human species and the increase in our numbers. Now, I'll present just a kind of a schematic of where we feel the boundaries are right now, and then Ben can go into a specific example of how this will increase our potential relative population density in terms of survival. We have to get back into space. All right. Many know that the American space program is in a tailspin down right now. The American space program is pretty much, it's in really bad shape. We don't have the power to get man into space anymore inside the United States. Other countries do right now. China, for example. Russia has the ability to put man in space, but in the United States it's collapsing. We have to get back into space. As a species, we have to get back into space. Now, the path to space is not necessarily with a spacecraft, because we also have to look at the development of the frontiers of the Earth. Getting back into space is not just putting people in space. It's developing a control over our ability to survive as spacefaring species, which means we have to learn, one, how to control the Earth. The control of the Earth begins up in the Arctic regions, which people may know. The Arctic has recently become a very hot topic in government circles, not just because the ice is beginning to recede and we can actually have transport of goods and materials up around the Arctic Ocean, and we can begin to develop the resources up there. So it's becoming a very hot topic. But the important aspect of Arctic development is that that's the cockpit of the Earth. It's where we have the aurora. It's where we have the northern magnetic pole. It's where the sun interacts most closely with the Earth. This is where all the cosmic radiation from the sun enters into the Earth system, is through the poles. Geomagnetic storms emanate from the geomagnetic poles, which is up in the Arctic. So beginning to develop the Arctic, beginning to move populations up into the Arctic and build cities, such as the proposed Russian city of Umka, this is the way that we'll begin to understand how the Earth interacts with the rest of the solar system, and thus perhaps get more and more conscious control over the types of processes on the Earth that cause things like weather disasters and things like that. So the route into developing our control over the solar system begins at the Arctic. Now, when we get into space finally again, we have to look at a crucial boundary that we have to overcome. That'll be the boundary that the major governments in the world will invest to overcome. The boundary is a space-time, a relativistic space-time boundary of crossing the distance between the Earth's moon to Mars in 1 week or less, 7 days or less. Now, the way you cross that type of a space-time boundary is by developing spacecraft that can accelerate for several days at a time at least 9.8 meters per second squared, which is Earth gravity. So you could put people on one of these spaceships, accelerate towards Mars, and within a week you could get to Mars, and the entire time people would have been on those spaceships experiencing essentially Earth gravity. All right, so they wouldn't experience the bone loss and other degenerative effects of prolonged weightlessness, which is what some of the current Mars programs call for. So we have to cross that boundary. What that means is we'll develop a control of getting to different places within the Mars orbit in a very short period of time, so we can do things like mitigate threats, mitigate asteroid threats, for example. Rescue stranded astronauts and cosmonauts, for example. We'll be claiming the region inside the Mars orbit. Now, in order to develop those type of spacecraft, one, we can't depend on chemical propulsion anymore. We have to go to fusion. Right? Fusion is the only current fuel source on the horizon which could provide that type of propulsion, possibly matter-antimatter. But right now, fusion is, that's what we have in our grasp to make a breakthrough in. So governments must invest in that. In order to develop it, in order to develop fleets of such craft, we have to look towards developing the surface of the moon. We have to start having permanent colonies on the moon, not just to have people there, but we want to have industry on the moon. We have to begin mining the moon. We have to begin having factories on the moon. We have to be able to build structures on the moon. We have to be able to construct spacecraft on the moon and within the space between the Earth and the moon, cislunar orbit. We have to build an infrastructure in between the Earth and the moon so that we can industrialize the whole area. Now, some may know that China and Russia currently do have plans to get back to the moon in a permanent way. We have to accelerate those plans and increase international collaboration on those plans. We need to increase, besides just developing the infrastructure between the Earth and the moon, we have to begin creating many more satellites in the solar system. Because once you begin to send people out into deep space, into the lunar environment, and then potentially out into the Martian environment, you'll begin to recognize that man is encountering not empty space, but that space is very, very dense with a variety of radiations which may be harmful to people. We know that a lot of them are cancer-causing radiations. But there are other forms of radiation that we may not even recognize exist yet. We need to begin flooding the space inside of Martian orbit with observational satellites of all bands of radiation to look at the sun and everywhere else in the solar system to measure and be able to warn people of these types of radiations. We have to begin to control the environment within the Mars orbit. So what we're going to be looking at is developing a whole new human civilization which is based in space travel and space development and the control of entire areas and control of the entire planet Earth through the Arctic, the control of the moon, the control of the entire region inside Martian orbit, which means that we have to look at the areas that we're controlling not as, wide, vast regions of empty areas, but they're complex topologies of space-time. And we have to learn how those topologies function so we can place our control mechanisms at the appropriate places, which means we have to have visionaries which can recognize what is the space that we're dealing with. So the future perspective thus entails an increased ability for survival of mankind through development of increased power and discovery of how to wield that power over the universe. Now, just as an appendix, and then we can go to Ben, how is this going to be paid for? We're in the terrifying throes of economic collapse right now. The European Union could collapse, the American economy is in shambles, and so forth. How do you pay for this? Do you have to show that the development of the Arctic or the development of the moon are commercially viable and are going to have a lot of monetary profit? No. You have to follow what has been the history of what's called the American system of economics, and specifically what Lyndon LaRouche has identified as the credit system, which is that a government has the power to incur a debt and then use that debt to invest into specifically science driver programs to increase man's power to exist. That doesn't necessarily increase man's power to make money to pay back the initial debt incurred, but it increases man's power to exist, which as a corollary, you'll be able to pay back that debt. But the point is that the government has a responsibility to give credit to the future development of mankind. Thus, we need a credit system. We need to wipe out this current monetary system. So with that, Ben.
Okay. I think from this vision you're presenting, Peter, I think we can now focus on the path we can take to get there, to achieve that. As Mr. LaRouche stated very clearly in his opening remarks in his keynote address, we have this current, multifaceted crisis in the world. And he made very clear we're at a point where we can no longer afford to have the types of conflict and warfare among nations, because we're at the point where that could lead to the self-extinction of the human species. And the alternative is exactly what you laid out and what's being discussed at this conference, which is a new vision for what mankind has to be. And as an integral part of that, as a beginning step for mankind taking that path into a new level of taking on these challenges, becoming a truly spacefaring species, we have this immediate threat of asteroids and comets. And so we're at a point where the international declaration needs to be no warfare among nations. We need warfare against comets and asteroids. Those are threats that mankind needs to come to deal with. And the only way we can do that is by these types of programs we're talking about here. So I want to just give somewhat of a sketch of what this challenge is, a challenge being placed before our generation and the coming generations to conquer, to actually secure the existence of mankind on this planet, secure the defense of this planet from these threats that we know will happen at some point in the future. We know at some point there's going to be another asteroid impact. We know at some point, maybe distant in the future, there's going to be some comet impact again. So the question is, will the nations of the world come together now to take the necessary precautions to ensure that we can increase mankind's physical economic power to deal with these threats? And so we in the United States have been very interested in some of the discussion to make this the focus of international collaboration. For example, you had a reference in the winter of 2011 from Dmitry Rogozin, who was then proposing to the United States that the United States and Russia should collaborate on missile defense systems, but also defending the entire planet from the threat of asteroid impacts. And we in the United States think that is exactly the right type of approach to international collaboration. We should be collaborating with Russia, but also China and India, and forming a new bloc of nations focused on the defense and advance and physical economic advance of mankind first and foremost. And there's a number of somewhat similar proposals, such as the proposal for the IGMOS system, a system of international collaboration and sharing satellite data, beginning to develop forecasting capabilities, forecasting earthquakes, forecasting volcanoes before they occur, monitoring the entire Earth to give mankind disaster response capabilities and forecasting capabilities, and including looking for asteroids and comets. So these are the types of programs that the powerful nations of the world right now should be focusing and collaborating upon. Because if you just look at the threat, if you look at the asteroid threat, for example, so I'm going to talk about, you have two classes of threats we should be focused on. First, you have the question of asteroids, and then we'll get to the question of comets, which is a qualitatively different threat. But if you just take even just the simple issue of asteroids, we're essentially right now flying blind through our own solar system. Even just the inner region of the solar system, say between the orbit of Mars and the orbit of Venus, you have a huge population of asteroids. Now, most people think of asteroids in the main belt between Mars and Jupiter, and the vast majority are there. The vast majority of the asteroids are in that region, the so-called main belt of asteroids. But you also have a very significant population of near-Earth objects, near-Earth asteroids as they're called, which orbit anywhere between, they can come closer to the Sun than Venus even, they can go farther out than Mars, but they have characteristics where they tend to, a large number of these tend to cross the Earth's orbit on a regular basis. So these are the bodies that we should be immediately concerned about, because if they're crossing the Earth's orbit, if the Earth happens to be there at that point when they cross the Earth's orbit, then you get an impact. And these impacts are actually much more frequent than most people would tend to consider. I mean, you have a whole range of sizes of these objects. Some are very large, a lot of them are smaller. And even these smaller ones, we know can cause major damage. Probably the most famous example is the Tunguska impact in 1908 in Siberia. And this is a relatively small object, relatively small asteroid or comet fragment. Maybe about 30 to 50 meters across, so not a huge object. But when it came into the atmosphere, it comes in at such a high speed that it literally, it's going from thousands and thousands of kilometers per second, smashing into the Earth's atmosphere, generating so much heat and slowing down so quickly that it literally explodes in the atmosphere. And what we think happened in 1908 was that this created a blast wave that came down over Siberia and then leveled an area of about 2,000 square kilometers of trees. Now, if you compare that size area, 2,000 square kilometers, with any major city in the United States, New York, Washington, D.C., San Francisco, you compare that with Moscow, you compare that with London, this would level any major city if it happened to hit over a major city. Now, the impacts of this size are relatively frequent, every few hundred years, we think. And but the problem is that we don't even know where most of these things are. If we can observe these and track their orbits, we can forecast years and decades into the future when they might intersect the Earth's orbit. If we know the orbital parameters of an asteroid, granted there are some uncertainties, and some of these uncertainties can become subjects of new scientific breakthroughs potentially in investigating them. But the only way to get to that point is to begin to map out the inner solar system. And based on current estimates from NASA and other organizations, we have discovered maybe around 8 or 9,000 of these near-Earth objects, near-Earth asteroids. And we have then their orbits mapped out. We forecast their orbits decades into the future, and we can then see if we think that it might impact next year or in 20 years or in 50 years. Now, 7,000 to 8,000 might sound like a lot, but the current estimates are that the total population of objects down to about the size of a Tunguska-sized object up to the largest objects is somewhere in the range of 500,000. So we have discovered about 8,000 maybe of a population of 500,000. So it's a little over 1%. So we're right now essentially flying blind through the inner solar system. And this is not even, this first issue is not even a huge technological challenge to deal with. We could be putting infrared telescopes in orbit around the Earth, in orbit around Mars, or around Venus, actually. Either maybe in an orbit around the Sun, similar to Venus's orbit. We could be putting these telescopes at the Earth-Sun Lagrange points. And we could begin to map this entire region. And so we can map this entire region and get a sense of this population. That needs to be done. There's been a lot of discussion about proposals for how to do that. And that initiative needs to be taken up, like Peter mentioned, populating the solar system with these satellite systems to get the kind of readings we need of these bodies. Now that's one first step. We should also be looking at the question of comets, and I'll just treat this very quickly because this is a qualitatively different and more challenging threat, because these comets come from the farthest outer reaches of the solar system. Now just to illustrate one example, in 1996, an amateur astronomer in Japan discovered a comet. When he discovered it, it was sometime in late January of 96. When he discovered it, it was just past the orbit of Mars, coming into the inner solar system. Now, in 2 months, since it was first discovered, we had no idea it was out there before then, had no clue it was coming into the inner solar system. And then we discovered it in late January. 2 months later, it passes by the Earth at 0.1 astronomical units. Now, in solar system terms, that's a close pass. There's been closer passes. You know, it's still a good amount of distance. But in terms of the solar system and the scales you're dealing with, that's a close pass. Now, this comet was about 4 kilometers across. If that would have hit the Earth, it would have had completely devastated the entire planet. That is a global effect. That's not just a small regional effect. This is not something that's 30 meters or 50 meters across, you know, creating an effect on a certain limited area. Once you get to the scale of 1 kilometer, 2 kilometers, 4 kilometers across, you're talking about global catastrophic effects. Now, this did miss with a good amount of distance. But the point to make is that we only had 2 months of warning time. Because these objects come from the far depths of the solar system and then come in to the inner solar system, with our current observation systems, we have little to no warning about when these things are coming. So this defines, so even though the comets are less frequent, this still defines an existential threat for the planet Earth and the solar system. And it defines some very interesting frontiers I just want to touch on, because if you take this particular comet, this one in 96, when we extrapolated what we think its orbit is to its full orbit to see when it goes back out into the outer reaches of the solar system, we think it actually travels out somewhere about 70 times the distance of Pluto. So we think Pluto's far away. This comet will go 70 times farther than that. It'll take it thousands of years to do so, but it'll go 70 times farther than we are from Pluto out into the outer reaches of the solar system. Now this is a completely unknown frontier area that we need to begin to think about, because the current theories are that this region is populated with trillions of cometary bodies. The current theories are that this so-called Oort cloud is a huge population of cometary fragments, comets and large bodies that orbit the entire solar system in these vast distances. And what we think is that as our whole solar system traverses through the galaxy, moves by other stars, moves through the spiral arms of our galaxy, moves up and down, above and below the galactic plane, as our whole solar system, as we have evidence from various sources, is moving through our galactic system, this whole body of cometary, this whole region of cometary bodies becomes perturbed and affected by these galactic forces. And it is thought that these can then perturb these bodies and then send them into the inner regions of the solar system. So the point is, this is not a question we're going to solve in 10 years. But these are the considerations that, as we know, have caused the extinctions of thousands of species in the past. There's clear correlations that indicate that as our solar system is traveling through the galaxy, you have periodic cycles of mass extinctions and then mass growth, mass expansions of new species, and the creations of entire new types of life on the planet. So if you take this long-term view of the interaction of the solar system and the galaxy, you're defining an entire new frontier that mankind needs to begin to understand and investigate. And now, again, this is not a thing that's going to be solved in 10 years or 5 years or something. But this is a generational, multi-generational perspective that we should be looking towards. And so these are the issues that nations should be focused on. You know, Mr. Larouche's idea is that the United States, Russia, China, India need to come together, form a new economic bloc, form a credit system to facilitate the types of economic growth that will improve conditions on Earth and expand mankind's capabilities into space. And as Peter mentioned, probably the pinnacle, the forefront mission in this should be the Mars mission. We need to take the question of asteroid defense, comet defense, and take it from this physical economic perspective. How do we increase mankind's power to defend the planet and improve the conditions of life? That becomes a science driver program. And the best science driver program we have right now that can be a generational, 1 or 2 generation program is the development of the defense of Earth, but doing that by developing the whole nuclear and thermonuclear capability of mankind, including thermonuclear propulsion systems, to ensure mankind's safe travel from the moon to Mars, which will also give us vast new capabilities for defending the Earth from these asteroids and comets. It will give us vast new capabilities of going out to intercept these bodies if we do need to intercept them. But this all becomes subsumed by one conception of mankind moving out into space, moving into a thermonuclear platform for the entire economy, a thermonuclear-based mode of action for all of mankind, and today getting the international agreements to commit to that mission for a generation or 2 generations. And the Mars mission should be a focus for that. So that is what we'd like to bring to the conference today, and we hope you enjoy your conference, and we'll talk to you again.